Okay, let's look at a slightly harder problem now. This problem might seem hard at first look, but it's fairly simple if you just go step by step. Okay, so also we don't know that this is directly an AP question. We have to figure that out as we go through. So the question says find the middle term of the sequence formed by all three-digit numbers which leave a remainder 3 when divided by 4. So I have to start off with all three-digit numbers. The first three-digit number I know is 100. Okay, so just in the first sentence, I know that I have to figure out the first three-digit number, that when divided by 4 gives remainder 3. Okay, so 100 is an even number and it clearly is not that number. If you want, I can just go through the division. So 100 by 4, I have 8 to 20, 20 directly, and 0. So 0. So 0 is the remainder. Let's check the next number, 101 divided by 4. So if see, I know that 100 is giving a remainder of 0. This is an increment of 1. 100 is an increment of 1. If I were to solve this, I go again 8, 2, over here 2, 1. I will pick 20. Quotient is 5, 1. Remainder is 1. Okay. So going by this pattern, you know that 102 will give remainder as 2. 103 will give remainder as 3. So the first three-digit number which gives us a remainder of 3 when by 4 is 103. Okay. What will be the next number? Now if I take the next number which gives me a remainder of 3. Okay, so if I go by the number, go in sequence, next number comes out to be 104. Now dividing this by 4, again I have 8, 2 minus 24, 24, 6, 0. So again I got a remainder of 0. Similarly 104 is giving me remainder 0. 105 will give me remainder 1. Clearly you can spot the pattern. 106 will give me remainder 2. 107 is the next number which is giving me a remainder of 3. 108, similarly again 108 will be 0, remainder 0. 109 remainder 1. 110 remainder 2. 111 gives us a remainder of 3 again. Now let's see the pattern. Okay, so 103 is the first number, 107 is the next number, 111 is the third number which gives a remainder of 3. Okay, so just seeing this pattern itself, I know that this is an AP. This is an AP where common difference is 4 and first term A and 3. Okay, this was the first part of the question. Let's move to the next part of the question. Let's see what the next part says. So also find the sum of all numbers on both sides of the middle term. So first I have to find the middle term. How will I get to know what is the middle term? Okay, so this actually leads us to a couple more important concepts. The first thing is which term is the middle term? That is the very first thing. And second is what is exactly the middle term? What is the value of the middle term? So let's try to look into both ways. So what we have to do is we have to first find the end of this AP. Only the end of this AP will give us the number of terms and hence the middle term. Yeah. So let's find the number of terms. Let's find the very last term which satisfies the condition that when divided by 4 gives a remainder 3. Okay. I'm trying to find the end of the sequence now. So the last three-digit number is 999. Okay, let's divide 999 by 4. I have 8, 2, 1, 9, here 1, 6, 4. Over here I have 39 and 36. 249 and 3. Okay, so I'm getting a remainder 3. Remainder 3 when 999 is divided by 4. So clearly the last term of the sequence is 999. So the sequence that is given in the question was 103, 107, 111, so on all the way till 999. So we need to figure the middle term. Somewhere here there is a middle term. We need to figure out what that middle term is. So far I've gotten the first 3 terms and the last term. So first term and last term I know. Let's figure out how many terms are exactly there, the number of terms that are there in this series or sequence. So I have 999. Let this be the nth term. This is the nth term. The nth term is the first term 103 plus n minus 1. I don't know what n is, remember that, times common difference 4. Common difference, as I said, marked over here, common difference is 4. Okay, and a, which is the first term, is 103. So this gives me 103 plus 4n minus 4, which is basically 4n minus 99. Okay, so you can see that this is a linear equation in n. N is a variable. Let's figure out the value of n. So n is basically, or rather 4n is 99 minus 99, which is 900. If 4n is 900, that gives the value of n as 900 by 4, which is equal to 225. A is 103, D is 4, and N is 225. Okay, now if N is 225, how many, which one do you think will be the middle term? Okay, so what we'll do is, we'll get an approximate value of the middle term by dividing this N by 2. So middle term, let's say the middle term is somewhere around N by 2. That will be close to 225 by 2. Now this exact value is 112.5, but obviously you can't have a decimal number term. Of course, you can either have the 112th term or the 113th term, but which one will be our middle term? Okay, so now we come to the only tricky part of this entire chapter in your 10th grade, in 11th grade, and so on. The only tricky thing is finding out the correct number term. Okay, so there's number of terms and correct number term. These are the two hard parts. Everything else is very easy in this chapter. So to break this concept down and make it simple for you to understand, let's take a series with only 5 terms. 1, 2, 3, 4, 5. Over here you can immediately spot that the middle term is the third term. Okay, so over here what I did was, I found out n by 2. I found out n by 2 to be 225 by 2. Let's apply the same concept over here. So n by 2 in this new series is 5 by 2, which is 2.5, and the middle term I know is the third term. So if I basically do n plus 1 by 2, remember this is reverse logic. I'm going in a reverse manner. I got the number of terms as 5. I spotted the middle term to be 3. And then what I'm doing is I'm trying to construct a logic using this to get the middle term. So n plus 1 by 2 is basically 5 plus 1 by 2, which is 3. So this number 3 is the middle term. So I have now created a logic to find the middle term if n is odd. Okay, so if n is odd, middle term is equal to n plus 1 by 2. This is a very important result. You can remember this, or even if you don't remember this, how to reconstruct it is using this logic. So just take a very small series with a number of terms as odd. I've taken the number of terms as 5 over here. Taken n by 2, give me 5 by 2, 2.5. I know that the middle term is 3, reconstructed and got that, okay fine, the formula for middle term if n is odd is this, n plus 1 by 2. Okay. What happens if n is even? If n is even, let's just do this again. So let's take a series with 6 terms. 1, 2, 3, 4, 5, 6 terms. Okay, remember these are just the number of terms. Over here 1, 2, 3, or 5 are number of terms. This is first term, second term, third, fourth, fifth. Over here I have a sequence or series with 6 terms: 1, 2, 3, 4, 5, 6. Okay, over here you can see that 3 is as far from the beginning as 4 is from the end. Okay, so we cannot say that only 3 is the middle term or only 4 is the middle term. In fact, both are the middle terms. We have two middle terms. Alright, the third and fourth. Now let's just construct a reverse logic for this. So if I take n by 2 to get somewhere around the middle term, if I take n by 2, in this case that is 6 by 2, that gives me 3, which is one of the middle terms. So 3 is one of the middle terms. And let me take the other thing I should get is 4 over here. So how do I pick the left hand side? How do I pick the left hand side such that the right hand side comes to 4 for this series? I can take n by 2 plus 1. Okay, so that is 6 by 2 plus 1, that is 3 plus 1, which is 4. So let's just generalize this. If n is even, you have two middle terms, out of which the first one is n by 2 and the second one is n by 2 plus 1. So this is also something new we learned just by solving this question. What we have done so far is we figured out n for this series. N was 225. We know that, so clearly n is an odd number of terms is odd. We're going to apply the first formula for middle term. So let's proceed with that. So the middle term is going to be 225 plus 1 by 2. This is basically n plus 1 by 2. Okay, so that's 226 by 2, which is 113. So the 113th term is the middle term of this sequence. Okay, let's find out the 113th term. It's going to be, I'll write T113. The subscript is for which term it is. T113 is 103 plus 113 minus 1 times common difference, which is 4. So this happens to be 100 plus 112 into 4, 48 plus 103, 551 is the answer. Okay, always so in a question like this, which is quite a long question, always try to verify at certain steps whether we are on the right track so far. So one thing I can do to verify whether this number 551 is somewhat correct is check the remainder when divided by 4. So when 551, let me just take an alternate color for this. When 551 is divided by 4, I get 4 quotient 1, 1, 5, 12, quotient 3, 3, 1, 28, quotient 7, and 3. So I'm getting a remainder 3. So this is verified to a certain extent. That fine. 551 is a number which gives us a remainder 3 when divided by 4. Alright. Now let's just quickly go back to the next statement of the question, what was asked. So also find the sum of all numbers on both sides of the middle term. Okay, so this is also going to take a couple of steps. It's very simple though. Yeah, so 113th term is the middle term. I need to find out the sum of first 112 and next 112, which comes from term number 114 to term number 225. Okay, I will leave this part to you to solve, think and solve, and I will just be solving this, the first 112 terms. This was what was the ask in the second statement of the question. So this sum is going to be n by 2. which is number of numbers, n is number of the numbers, that is 112 in this case, multiplied by 2a plus n minus 1 times d. Okay, so if I substitute all the variables over here, I have 112 by 2 into 2 times 103 plus 112 minus 1 times 4. Okay, so you can solve this. Also, another way to solve this, I'll just give you another quicker way to solve this. I can take it as n by 2 number of numbers into first plus last term. Okay, and over here I know the first term already. The first term is 103, so you have n by 2 into 103 plus the last term is the term just before 551, the term just before 551. So if I subtract 551 by 4, I have 547. So this is also the answer. This will be even shorter, but of course both the methods will give you the exact same answer. We can check that. And the final answer from both of these will be 36400. This will also give us 36400. Okay, so it's I'm not doing this solving this. You can do on your own basic math. All right. So we have the answer for the first 112. Similarly, you can find out the sum of the last 112 as well. The numbers going from 114 to 225. Over here, you just have to replace the first and last with the 114th term and the 225th term. So I can just write this as n by 2 into, so the 114th term will be the one immediately after 551. So that's going to be 555. And the last term we already know is 999. Okay, let's just recap the problem once, since it was quite a long problem. So over here I've written down all the pointers. The first thing was that we did to find the first number which gives a remainder 3 when divided by 4, that is 103. This was the first step. The next step was to find the last such number. So last 3-digit number which gives a remainder 3 when divided by 4, that happens to be 999. Now the next step was to find the number of numbers. So if I have the last term, first term and common difference, I can basically find the number of numbers. The number of numbers turns out to be 225. Alright, after that I got the index of the middlemost number. The index of the middlemost number is 113. I got this by doing n plus 1 by 2. This turned out to be 113. And this number was 551. Now I'll just give you a couple of interesting pointers. So if I take the first number, that is 103, plus last number 999, and divide by 2, this would give me 1102 by 2, which is nothing but 551. So immediately by doing this I can actually get the middlemost number, but the problem over here is the same thing will not work for number of numbers being even. So if the number of numbers, instead of 225, say it was 226, okay, in that case I cannot just directly get one middlemost number. So this works out for the case when n is odd. So if the number of numbers is odd, I can just do this to get the middlemost number. Take the average of the first and last to get, in this case, the 113th number, which was 551. So this is one interesting pointer. Now, after getting the middlemost number, we have to find the sum of numbers from T1 to T112 and T114 to T225 by constructing two different APs. So in the first AP, T1 remains 103 and this last term becomes 547. In this AP, this term becomes 555 and this last term is 999. I would like to add a couple of more things further, going a bit deeper. I do understand that this problem is fairly long, but there's a lot to learn from these slightly longer problems. So another thing is the number of numbers turns out to be 225. Okay. Now the total number of 3-digit numbers, yeah. So going from 100 to 999, all 3-digit numbers, how many number of numbers do I have? So say I'm going from A to B, where A and B are integers, you can say that they're integers, the number of numbers turns out to be b minus a plus 1. Okay, I won't get into the explanation of this, but this is basically the number of numbers, and applying the same thing to this scenario where where you have 100 and 999, you get 999 minus 100 plus 1. So this is basically 900. So I have 900 numbers. Alright, and 900 divided by 4, just look over here. 900 divided by 4 happens to be 225. So I will explain this right now. If you want, you can skip this part of the video. I'll just mark on the timer when exactly what all parts you can skip. Of course, there's a lot of added info I'm giving for our own general knowledge in math. So one thing is, you see that we are finding out in the condition given in the question that all the numbers when divided by 4 give a remainder 3. So we are finding out all the numbers with a gap of 4 places. That what that means is we are basically finding out we're looking at 1/4 of the total numbers. Okay, so the total 3-digit numbers was 900. We're looking at all the numbers with the spacing of 4. That is basically close to 900 by 4. In this case, it's exactly 900 by 4. But I'll tell you, even in a general case, like say if you have number of numbers as suppose A, and we are looking for all the numbers with a certain spacing. Spacing mean that common difference in the AP. Then approximate value will be A by B. So it's actually better if I use the standard notations. The number of numbers n in this case will be total number of numbers being considered. Like say with 3 numbers, I have capital N as 900, and this divided by the common difference. So n will not be exactly equal to this, it will be in fact approximately equal to this. And I'll also tell you that it could be a plus minus 1 compared to this. Okay, so this is something you can think of on your own. It's just an interesting point of observation that instead of doing getting the number n by solving the linear equation that we did, the linear equation was something like this, where you have 999 equals a, that is 103, plus n minus 1 times 4. We solve this in order to get the value of n. Instead of doing this, what you can do is I can just get, okay, from 3-digit numbers and 900. I'm looking at all the numbers with a spacing of 4, 900 by 4, straight up 225. Now whether it's going to be plus minus 1 or 0, plus minus 1 or 0, I have to apply with some other logic. Okay, but this gives me an approximate idea.